here, let me scroll up a little bit, put it under. It's a very interesting problem, actually. I gave this a lot of thought because I was trying to solve it. I thought it said ST bisects VSX. So I thought that was equal to that. That's not what it says. It says ST bisects angle VSW. Not even VSX. It's VSW. I really misread it. So it's not, those two lines are the same. It's these two angles are the same. So what does that make each of those angles?
It makes them equal.
And also all three of them have to add to 180. So what does it make them?
It makes them supplementary.
Makes them 70 each.
Oh, yeah.
In other words, 1, 2, and 4 add to 180. So 1 plus 2 adds to 140. And since they're equal, they each must be 70. And if number 1 is 70, that is 70 based on parallel lines. And if that is 70, that is 70. So this is really an easy problem. Notice how you can figure out. I worked on this for about 15 minutes trying to solve it, thinking that TS bisected that line. I finally realized that you couldn't solve it that way, because I can change the angle that TS hits. And if I change that angle, I got to change that angle. And if I change WX, then it changes angle W and changes angle X. So there's no way I could be allowed to change the rotation of TS.
Okay.
And I didn't need to anyway, because it said it bisects that angle, not that line. All right. I think we did 9. Do we want to back up here and go to the next document?
Yeah, number 10, I think.
Okay. A Crook Problem. I love these. You will see one of these on the SAT. Angle 8 is 150 degrees.
Yes.
In other words, it's what I call an M problem.
Okay.
And it's typically going to be rather hard to solve, but I just happen to have memorized this. And by an M problem, I mean if you have a crook and it forms an M like that, then angle 1 is equal to angles 2 plus 3, always.
Okay.
Now, if I didn't happen to know that, most people wouldn't know that, then I've got to solve it by extending one of these lines to there. And now I know that this has to be 70, right? This is 80. That makes this 30. And that's a linear pair, so that makes 8 equal to 150. So that's the way you would normally solve it. is by extending the line. Either you could extend that line or you could extend that line. But once you extend it, you have a complete transversal, and you can figure out all the angles involved.
Mm-hmm.
But look for this, the Crook problem. I didn't know what she meant when she said that. I call this the M problem. In other words, if I rotate this whole thing 90 degrees left, I'm looking at an M.
Yeah.
But it's always that way, where that angle 8 is equal to that angle 70 plus angle 80. All right. So number 11, is that the one you want to do next?
Yes.
Okay. So AD is, I have a bad habit of misreading these. And so I find it very helpful to go ahead and label up the thing as we're doing the problem. That's the given. Name all pairs of angles that must be congruent. Okay, now let's do this.
Okay.
And there are a number of transversals. Let's talk about that transversal first. So what has to be congruent?
6 and 3, 2 and 5, and then, yeah.
That's all in terms of the ones they've numbered.
Yeah, because there's no numbers on the
Right.
X.
There are other congruent angles there. That angle is congruent with that angle, but they didn't number those, so I assume they don't want us to include those. So let's look now at that is also a transversal. Well, unfortunately, let me get rid of all my numbers here. Presuming that they only want us to talk about the numbered angles, well, if I have that and that transversal, the only angle they're talking about is 4.
And D.
Well, and that one, right?
Yeah.
But that's not numbered. So I don't know. We don't really even have a way of identifying that. If you'll notice, if I wanted to talk about that angle, I couldn't. It's what? CD what? Nothing. So clearly they don't want us to refer to that angle. Let's just, for the heck of it though, check this other transversal. This one here.
It doesn't have anything either.
Well, 1 is that one. But that would be congruent to that one, which is not numbered. It would be congruent to that one, which is not numbered. So I don't think we can talk about those either. Now, the mistake that they want you to make here is to assume that CD is parallel to AB. And we cannot assume that. They don't say it. In other words, CD is not necessarily parallel to AB. So we cannot assume that. All right, let's go to the next one. One of the sides of that triangle has a midpoint whose x coordinate is negative. Well, that's got to be right there, right?
Yeah.
In other words, it can't be this side BC, and it doesn't look like it's AB. The midpoint of AB looks to have an x coordinate that's positive. Okay. And they didn't really need to, yeah, I guess they did need to tell us that. Find the coordinates of that midpoint. So how do you find the coordinates of that?
You just x plus,
You got it. X1 plus X2 divided by 2.
over 2, and then y1 plus y2 over 2.
Okay.
And then that's
So what is this one, first of all?
x1, so that'd be -4. And then divided by 2 would be 1.
-4 divided by 2 is -2.
Yeah, no, I don't know why I said that.
It's all right. And the y coordinate?
4.
Right. Okay. It's a strange way to ask the midpoint formula by drawing this huge picture with a triangle.
Yep.
All right, 13. A is parallel to B. Solve for X and find angle 1. Okay.
So could you do 2.14x is equal to x plus 22.4808?
Yeah. Must be some reason they use numbers like that. It must go in exactly a certain amount of times.
Mm-hmm.
So I'm going to move the X to the left.
Yep.
And then I'm going to have that. And you have your calculator?
I don't.
Here, I've got mine. Got to believe that's a whole number. 22.48 divided by 1.14. Yeah, I get 19.7, which means it's probably 20. Here, let me do it fully. 22.4808 divided by 1.14. No, 19.7.
Did you forget the 2.14?
Well, it's only 1.14. In other words, to solve that equation, I got to get the x's all on the same side. So I subtracted an x from both sides. And that left 1.14 and this number. And so now I divide both sides by 1.14 and I get x equal 19.7. So angle 1 is what?
19.7.
Times?
Times 2.14.
Okay.
And that would be
Whatever that is. I don't know why they give you such odd numbers. Is that an even number?
19.7.
Probably not, because it was 19.7 n digits. It was 19.726315. So that, here, let me multiply that by 2.14, see what I get.
I got 42.158.
Yep. Oh, I get 42.21. That's round off error. That's why it puzzles me that they would give you problems that don't end in clean numbers. It's all right. All right, let's look at number 14. Problem set B. What does that mean? That means it's harder than problem set A?
No, it's just, I don't know why they do that. It's just a different.
Okay.
It's the
Okay. So FJ is not parallel to KO. FH is parallel to MO. And HK is congruent to MJ. HK is congruent to MJ. So that distance is congruent to that distance. Mark it like that. Prove that FH is congruent to MO. Well, right off the get-go, when you see prove that, what do you know you have to do?
You have to prove that the triangles are congruent.
Probably, almost certainly. I don't
think
know for sure that that's what we have to prove, but almost for sure.
Doesn't it say prove FH is not congruent to MO?
You're right. It does say that. Wow. Okay. That could be more difficult to prove. Well, if we look at this again, let me erase what I've got on there. It's relatively easy to prove that that's congruent to that, right? JK is equal to itself. Subtract JK from each, you get HJ equals KN.
Yeah.
Because FH is parallel to MO, what do I know? Let's just talk about angles and sides for the moment.
We know that angle M equals angle H.
Okay. So we have side angle. If FH was congruent to MO, if it was, these two triangles would be congruent, correct? If those two triangles were congruent, those two would be parallel. So since it tells us that FJ is not parallel to KO, then there's no way these two triangles can be congruent. The reason, first of all, if FH was congruent to MO, I say these two triangles would be congruent because it's side, angle, side, right?
Yeah.
Okay. And if these two triangles are congruent, then that angle would have to equal this angle right here. And if those are all equal, in other words, if we have 3 equal sides and 3 equal angles, FJ has got to be parallel to KO. So when they tell us this, it absolutely means that those two triangles are, first of all, not congruent. And if they are not congruent, then FH cannot be equal to MO. Because otherwise the triangles would be congruent and FJ would be parallel to KO. It's an interesting problem. I rarely see problems where you try to prove non-congruency.
Yeah, they usually do congruency.
Yeah. I haven't seen a problem like this in a long time with a lot of geometry students. So it's a little different. All right, let's look at 15. And
can we go to 17?
Sure.
It'll be on the next page, too.
Yep. All right, if DA is parallel to BC, is ABC equilateral? And if it is, find the measurement of DAB. Well, first of all, if it is equilateral, what's the measurement of DAB?
DAB. It would be 60.
Yeah, it would have to be. Because if this is the equilateral triangle, that's going to be 60. They're both x, so that would have to be 60. That would have to be 60. Okay. So let's see if we can prove whether that's equilateral. Okay, here's our two parallel lines. There's the transversal. So y is equal to what?
Y is equal to y?
No, here, let me draw it again. There's the top parallel line. There's the bottom parallel line. There's the transversal. Think alternate interior angles. Y is equal to what? What's that equal to?
Y?
No, it's equal to the alternate interior angle.
Oh, x. Yeah. I was looking at the bottom.
No, y is equal to x. So that definitely means that these have to all be 60 if y is equal to x. And if y is equal to x, that's 60, which makes that 60, which makes that equilateral.
Yeah, because it's equal to x. Obviously, x is equal to x. So, equilateral.
Yeah, once you prove that y is equal to x. All of these parallel line problems, they try to make them more difficult by adding extra lines in there. In other words, we actually have we got two parallel lines, but we got two transversals. We got that one and then that one. Well, I didn't need the other one. I was able to solve the problem completely by just doing the one transversal. And a lot of times it's easier to see the problem if you're only looking at one transversal like that. In other words, clearly I can see that that angle is equal to that angle. So y is equal to x. I don't have to pay any attention at all to that transversal. But a lot of times the difficulty when you have parallel lines and transversals is seeing the transversal that you want to see. In other words, it really is. If they made all the problems look like this, they'd be easy. But they don't. They make some of them look like this. In other words, it's not the simplest case scenario. All right, what after 17?
18 and then 22, and then that's all I have.
Okay.
So, yeah.
18. Let's look at it. What time did we start?
4 o'clock.
4 o'clock? We've only been doing this for 20 minutes?
Yeah.
Wow.
Time flies.
Usually time flies when I'm having fun, and I'm having fun, but it seems like we've been doing this for more than 20 minutes. Okay. Explain why lines M and N are parallel. What do I have to do to show they're parallel?
You have to prove that the angles.
Forget about it differently. Forget about congruent triangles and parallel lines and transversals, and think about it in a different way. What causes two lines to be parallel?
Oh, same slope.
Yeah, exactly. So explain why they're parallel. We got to figure out what the slope of line M is. Well, we got a point there and a point there. Figure that slope out. We got a point there and a point there. We can figure that slope out. So what's the slope of line M?
X1 is...
It's the Y on the top. X is on the bottom.
Oh, yeah, Y on top, 9 minus 4 over 3.
And what is the slope of line N?
4 over 3.
And that proves they're parallel. And that's all we need. You could get lost trying to prove congruent triangles and parallel lines and angles and everything if you took the wrong path there.
Yeah.
Okay, so 22, you said?
Yeah.
Okay, here's a simple parallel lines with a transversal. This should be very straightforward. They're giving everything to us in terms of variables. So what can I write? I need to write some equations because I'm going to have to solve for these variables.
X plus 3y equals 5y plus 20.
Can I solve that?
No, because you have two variables.
Because I have two variables and only one equation. But I got another equation I can write.
2x plus 30 plus 5y plus 20 equals 180.
I simplify both equations. I end up with x equal 2y plus 20 in the top. That's equation number 1. In other words, I'm going to have a system of equations here. And in the bottom, I get 2x plus 5y equals 130. Now, how am I going to solve this? 1 and 2. By substitution or elimination?
You can substitution.
Yeah, whenever you have one of your equations fully solved for a variable, like 1 is, I think substitution is the easiest way to do it. So if I substitute it, then 2 times 2y plus 20 plus 5y equals 130. Instead of I will distribute it. So we got 4y plus 40 plus 5y equals 130. That looks like 9y equals minus 10. What is going on?
I don't know. That's not
possible.
Yeah.
Okay, let's try this again. The only thing I would have done differently from what you did was you made these two supplementary, which is big numbers. I would have made 1 and 2 supplementary because it's smaller numbers. So let's do that and see if we get anything different. So x plus 3y, that's angle 1, plus 2x plus 30, that's angle 2. That has to be 180.
So minus 30.
And then angle 1 has to be equal to angle 3. So that would be x plus 3y equals 5y plus 20. Now let's see. If we simplify the top, we get 3x plus 3y. 3x plus 3y equals 150. Can actually simplify that quite a bit by dividing both sides by 3. So I get x plus y equals 50. That's my equation number 1. Equation number 2. Let's put everything on the same side and solve it by elimination this time. X minus 2y equals 20. So there's my equation 2, there's my equation 1. And now I can merely subtract one from the other. Are you confused yet? Here, let me write equation 1.
Yeah.
Equation 2. Now they're both in standard format. So it's easiest to solve them by elimination. I'm just going to subtract the two of them.
Yeah.
Well, what do I get? I get y minus a minus 2y, which gives you plus 1y equals 30.
Yeah. And then you can substitute that into
this one. So if y equal 30, x equal 20. And that means angle 1 is 20 plus 90, 110. Angle 2 is 40 plus 30, which is 70. Notice the drawing is not drawn to scale. That's okay. Normally we would have a note there saying not drawn to scale, but this works fine. And angle 3 is 5 times 30 plus 20. That's not right. $150 plus 20, that would make it 170.
And then those wouldn't be equal.
Well, no, there's no way that line's 170 either. It's got to be 110. So what's going on here? Is this the last problem?
Yeah.
On the entire thing?
Yeah.
Is it possible they gave us one that couldn't be solved? In other words, it doesn't have a solution.
I don't think so.
All right, let's do it again. 1 is equal to 3. Let's start out there. X plus 3y equals 5y plus 20. Has to be a true statement, right?
Yes.
Okay. And furthermore, angles 1 and angle 2 are supplementary. So x plus 3y, which is angle 1, plus 2x plus 30, which is angle 2, has to equal 180. Which is 3y plus 3x equals 150.
Then you divide it by 3 on everything.
Y plus x equals 50. And let's see, that was what? That was angle 1 and angle 2. So we're going to use that as our second equation. So let's get rid of all these. And this equation here is, if I bring the y over to the left, I get x minus 2y equals 20. And this is x plus y. So here's my two equations. I'm going to subtract them. Y minus 2y is 3y, not 1y. I just made a math error before. So y is 10. And x is 40 because the sum of them was 50. So now let's see if everything is correct. If y is 10,
y is 30 plus 40, so that'd be 70.
So that's 70, and it looks like 70 this time. And 2 is 80 plus 30, 110. And 3 is 50 plus 70, or 50 plus 20. Perfect.
Now we got the correct numbers.
Yeah, it shows you how one little math error can really screw you up. Especially when you go back and do it again and you make another math error or doing it a different way. But I think you knew how to do it all along. It was just a question of getting the arithmetic right.
Yeah.
All right. Well, Joseph, you know this stuff pretty good. Or how are you doing in geometry?
I got 100% on my last quiz, so
I'm not surprised. Good for you. Very good. Yeah, I mean, you haven't failed to be able to answer any of the things we've done here. So.
Yeah.
All right. Well, I presume that we're done for tonight?
Yep. We didn't really have that much to do.
That's fine. Hey, as long as you're getting 100, don't need to do an hour if you only got a half hour worth of material. So, good for you, Joseph. I will talk to you next time.
Yep. Thank you.
Bye-bye.
Bye.